everyone. This experiment is about Thevenin and Norton theorem. Based on this theorem, every circuit has an equivalent Norton or Thevenin circuit. Let's start from the Thevenin. Each circuit could be modeled as a voltage source. We call it V Thevenin, and a resistor, we call it R Thevenin, which is modeling the circuit. So up to here is your circuit, and then this could be connected to the load. So load is connected here, our load, and you can basically do the measurements here on V Thevenin and R Thevenin. And if you want to consider the equivalent Norton, the Norton is modeled as a current source, which we call it I Norton, and in parallel with a resistor, which we call it Norton resistor, Rn, and this is the equivalent of the circuit up to here. So I can connect it to a load, which could be a variable load. What we do in this experiment, we change the load and we measure the current here, the current IL, and we measure the voltage here. Let's call it VL. So we use a voltmeter and current meter, and in this way we are going to plot the values. So IL is going to be here and VL is going to be here, and in an ideal case we are supposed to have a line. So let's say for two values, IL1 and IL2, I'm going to have the equivalent value VL2 and VL1. So if I calculate the slope of the line, the slope is going to be VL2 minus VL1 divided by IL2 minus IL1, and it could be proved that this slope is to the negative of R Thevenin. So what you need to do in this lab is to draw this graph. So you first do the measurements and you enter the measurements into an Excel sheet, and then you calculate the slope. There is a formula in Excel that you can calculate the slope, and from the slope you reach to R Thevenin. So this is the way you calculate R Thevenin. And also the Thevenin voltage could be calculated based on the open circuit test. So for open circuit test, the current is equal to 0. So current equal to 0 means that I am at this point. So it means that the y-intercept, so the y-intercept is equal to V Thevenin. So basically this point is V Thevenin. And this is the way we calculate R Thevenin and V Thevenin in the first experiment. Next experiment is the maximum power theorem experiment, which is indicating that the maximum power is transferred to a load if the load resistance is equal to the Thevenin resistance. So basically it says that if you have an equivalent Thevenin network, V Thevenin, R Thevenin, and you have a load which is changing our load, the maximum power, so max power, is happening if our load is equal to R Thevenin. And we are going in this experiment to do some measurement and prove this theory. So what we do, we measure the voltage here. So you connect this to a voltmeter to measure the voltage, and then you also need to measure the current IL. Basically IL could be measured from the power supply. So let's say if this is your power supply, you read the voltage here, and you can read the current in the next display, because IL and I source are the same, so it means the current which is drained from the power supply is the same. Basically the current which is read here is equivalent to I load, so you really don't need to like insert a current meter to measure the current. Current is basically read from the power supply, but for the VL you have to have a voltmeter here. So for each case you have RL, and then you multiply IL times VL to get the PL, and then you draw the graph of PL over RL. Basically you should get something like this, and the peak, which is the maximum power, should be almost equivalent to R Thevenin, which was calculated from the first experiment. So we have R Thevenin from next experiment, and in the second experiment we should just experience that this peak is happening at R Thevenin. Next experiment is about superposition theorem. Based on this theorem, if you have multiple sources, current source or voltage source, to find the output voltage on the load, you can consider the individual voltages and then consider all the other voltages to be as the short circuit, and then if you measure the output voltage and add them together, that would be the voltage as if all sources existed from the beginning. So to be more clear, I'm going to give you an example. So consider voltage source V1 here, and with a resistor here, another voltage source, let's say V2, and then resistor here, and then let's say you have a load resistor, and let's say the target is to find the output here, so VL. Basically what it says, let's consider V out 1 to be the voltage across the resistor if V1 is present and V2 is short, and V out 2 is the voltage again across the load resistor if V1 is short and V2 is present. If we make these two assumptions, then superposition theorem says V out, which is actually the voltage across the resistor RL, is equal to V out 1 plus V out 2. So this is what we have from the theory. In the experiment, what we do, we're going to have multiple sources, and the multiple sources that we have in this experiment is a voltage source. So we have a voltage source. So this is the circuit that you have in lab manual, and a current source. So you have a voltage source and you have a current source. In order to do that, you need to use the power supply to provide you both voltage source and current source. So next video is going to show you how we can set up the power supply to give you the voltage source and current source at the same time, and how we can do the measurement based on the superposition theorem to find out the voltage. So what you do, first you connect the voltage source and current source at the same time, and this is my R load. So I'm going to measure VL. So I'm going to measure the VL when IS is there and VS is there, which is something that we are going to show you very soon in next video. and then I'm going to consider VL when VS is present and IS is short, is open circuit, because this is the current source. And then let's call this one VL1, and VL2 is when IS is present and VS is short. So in this case we need to prove that VL is equal VL1 plus VL2, and in this case if this equality is valid, then it means that the superposition theorem is valid as well. Before we show you the video about how to set the power supply to give us the constant current source here, this one, and the constant voltage here, I wanted to emphasize that the superposition theorem only applies to voltages and currents. It doesn't apply to power, because you know that the power is not a linear parameter. It follows the square law relation, because P, the formula says P is V square over R, or is equal to RI square. So you can see that V is following a square law, therefore the superposition doesn't apply to power. So basically you cannot say P is equal PL1 plus PL2, because this is not correct for a nonlinear relationship. So next video is going to show you how to set up the power supply to give you two different sources at the same time. For superposition experiment, you need two power source. One voltage source, as you can see in the picture, there are three resistors. If you look at the circuit diagram in the lab manual, you need a voltage source, which is here, and you need a current source, which is connected to the right side. So in order to do that, these two cables are connected to the 6 volt and the 25 volt. I'm going to use the 6 volt terminal for the voltage source, and I'm going to use the 25 volt terminal, make sure it's connected to the plus 25, as the current source. So from the previous experiment, you know that I have to set it to the CC mode. So let's say first to set up the 6 volt voltage. So I'm going to press on, at first I have to set the power on, and then press on the 6 volt. You can see that it's showing 6 volt on the display, and then you turn the knob to change it to whatever voltage is needed. I think 5 volt is needed, so I'm going to set it to 5 volt. .3, 4, 5, 6, 7, and let's say this is 5 volt. So when you set this to 5 volt, it means that you can get 5 volt from this terminal. Now I'm going to set the other one, 25 volt, to the constant current mode, because I need a current source. So I'm going to click on 25 volt. First you have to increase the voltage, so 6 and increase it to a higher level, let's say 24 or 20. So just a high voltage, because you want to make sure that you can get enough current out of the power source. And then I'm going to click on the display, and then next one click on the voltage current source, and then you have to lower the knob so that this shows 0 and the constant current, the CC mode, is shown here. Then you have to press the arrows to go to the least significant digit. So this one is flashing, the lowest digit, and then I increase the knob to get 1, 2, 3, 4, 5. The moment you see the CV, it means that you went to the CV mode. So you decrease it, and then you go to 2, 3, 4. The experiment is asking for 5 milliamps, so I have to increase it to get 5 here. Make sure you see CC here, because eventually if it changes to CV, it means that you're out of the constant current mode, so you have to again lower the knob all the way to 0 and then increase it until you get CC and the milliamp number, whatever it is, 4 milliamp or 5 milliamp in here. So in this case, both voltage source and current source are set up, and these power supplies can output two terminals at the same time. So it's not that you only can get one source voltage or current from this power supply. For this experiment, I am outputting two sources to the circuit. So this was about the superposition experiment, and make sure you follow all the like hints and rules that we showed in this video. Thank you. Good luck.